Hey dudes, in this video we're going to learn how to implement a spatial audio system with dynamic acoustics for 3D games in Godot 4. First of all, what does that even mean? Well, imagine you're holding your phone and you start playing some music. If you set your phone down on the ground and start walking away, the farther away you get, the quieter it sounds, and the closer you get, the louder it sounds. Godot already supports this functionality with the Audio Stream Player 3D node. Now imagine you're holding your phone again and you walk into a medium-sized room with tile floors. Well, now the music is going to bounce off the floors and walls and sounds like it echoes a little bit. This effect is called reverb. Finally, imagine you leave your phone in the room playing the music, but you walk into a room next door. You still hear the music, but since it's going through a wall, it sounds quieter and a little muffled. These are the effects we're going to add in this tutorial. First, open up Godot and create a new script called Spatial Audio Player 3D. Set the class name as Spatial Audio Player 3D and make it extend Audio Stream Player 3D. We want to be able to use all the built-in features of the normal Audio Stream Player 3D, but just add our dynamic effects. Now let's create a new scene with the type set to our new Spatial Audio Player 3D. Let's name it the same name as our class type as Spatial Audio Player 3D. In this new node, we're going to add multiple Raycast 3D nodes. We'll use these Raycasts to determine what our environment looks like so that we can dynamically adjust our audio. Raycasts are basically like a laser beam that you can aim and shoot, and it'll tell you if the laser hits anything and the exact position that it hit. A perfect audio system would have an infinite number of Raycasts pointed in all directions to determine exactly how our environment is shaped. But we're just going to simplify this into a few directions. You can add more if you want a more precise audio system. Add the first Raycast and rename it Raycast Down. Set the target position to 0, -100, and 0, and the collision mask to 4. The target position is the point that the Raycast is shooting at, and for this audio system, we'll only check objects on collision layer 4, which means all our walls and floors need to have this collision layer set. You can change this to whatever collision layer you want to support. If you do use 4, let's name this collision layer Spatial Audio so we don't forget. Okay, let's add the rest of the Raycasts. Raycast left will have target position 100, 0, 0. Raycast right will have target position -100, 0, 0. Raycast forward will have target position 0, 0, 100. Raycast forward left will have target position 0, 0, 100 and a rotation in Y of 45 degrees. Raycast forward right will have target position 0, 0, 100 and a rotation in Y of -45 degrees. Raycast backward right will have target position 0, 0, -100 and a rotation in Y of 45 degrees. Raycast backward left will have a target position 0, 0, -100 and a rotation in Y of -45 degrees. Raycast backward will have target position 0, 0, -100. Raycast up will have target position 0, 100, 0. The final Raycast is dynamic, so just name it Raycast Player. This one will look from the audio player directly at the player to see if there are any walls blocking line of sight. Alright, this node is done, so let's go back to the script and add the following export parameters. Max Raycast Distance is the max distance each Raycast will travel before it gives up. Update Frequency Seconds is the amount of time between each spatial audio update. Max Reverb Wetness is the max amount of reverb wetness we'll apply to our audio, and Wall Low Pass Cutoff Amount is the low pass cutoff we will apply if our listener is standing directly behind a wall. Now add these parameters, which will just keep track of everything. Next up is the audio bus index and name, which is how we keep track of the audio bus this player is tied to. Now add the effects variables to keep track of our audio effects. Finally, add the target parameters, which will be the values we set for our effects. Okay, we're ready to make the ready function. The first thing we need to do is create a new audio bus so that we can dynamically set audio effects. To interact with audio buses, Godot 4 lets you use the audio server, where each bus has a bus index. Now that we have the audio bus, we need to add the effects we'll be using to our new bus. For this tutorial, we are going to add reverb and a low pass filter. Next up, we don't want our audio to play until the effects have loaded, so we'll capture the target volume and set the current volume to be super quiet. Now we need to set all of our Raycast values again, but it needs to take into account the max Raycast direction from our export parameter. So instead of a distance of 100, it will use whatever is set in the export param. You might need to pause the video to copy all these over. Now to keep track of all of our directional Raycast objects, we need to add them to our Raycast array. Alright, the ready function is done. There are now 3 main things we need to do left. We need to figure out what the environment looks like by using our Raycasts. We need to figure out what target values we want to set for our reverb and low pass filter by using the environment. And finally, we want to lerp all of our effect values to the target values. First, we'll make a new function called onUpdateRaycastDistance. It will take a Raycast object and a Raycast index. The Raycast index corresponds to which Raycast this is in our Raycast array we made in the ready function. Okay, first check the Raycast to see if it hits anything by calling getCollider. If it does hit something, update the distance value for this Raycast in our distance array. If it does not hit anything, we'll set the distance to -1. This function is done. We'll actually call it later on, but for now let's add our audio effect functions. Next, add the following functions: onUpdateSpatialAudio, onUpdateReverb, and onUpdateLowPassFilter. Low Pass Filter. All of these functions will take a node 3D that will represent where the player is located. Let's start with onUpdateReverb. First, we'll just check if our reverb effect is valid. Next up, we want to find 2 values for our reverb effect by using the Raycast distances. Room size is how large our room is, and wetness is how much of the reverb effect we want to apply to the audio. For each distance in the distance array, if the Raycast distance is greater than 0, we'll update the room size parameter to find the average size of the room by using all of the Raycast distances. Remember, we set the distance to -1 if the Raycast reached its max search range and didn't find anything. So if the distance is less than 0, we'll reduce the wetness parameter for each Raycast that didn't hit anything, which will reduce the reverb effect. Finally, we'll update our target reverb wetness and target reverb room size. You could set these directly in the reverb effect object, but it could sound harsh if it transitions from a large number to a smaller number immediately, so we'll lerp to these target values later on. Now we can move on to onUpdateLowPassFilter. First, we'll use the Raycast player node and point it to the player who should actually be listening to this audio. Now we'll init a low pass cutoff value to a super high value and check if the Raycast hits anything. If it does hit something, we'll check if the distance to the position of the object that it hit is less than the distance to the player. If it is less, then that means there's something in between the player and the audio player. So we need to set the low pass filter cutoff frequency to our export parameter wall low pass cutoff amount, but we'll scale it by a ratio. The lower the cutoff frequency, the more muffled the sound will be because it's removing high frequencies in the audio. The ratio that we're scaling by is the ratio of the distance from the audio player to where the Raycast hits something versus the distance between the audio player and the actual player. By scaling the frequency cutoff by this ratio, it will more accurately muffle the sound if the player is far away from whatever is blocking the audio player. Alright, now we'll finish the onUpdateSpatialAudio function. This function will just call our other effect functions. If you want to add more effects, you can just make more functions and add them here, but we'll only be using reverb and a low pass filter. Alright, so we have functions to generate what our environment looks like and to find target effect values based on the environment. We next need a function to actually lerp these effect values so they smoothly get set. Create a new function called Lerp parameters, which takes in delta. Volume will get lerped to the target volume, the low pass filter cutoff will be lerped to the target low pass cutoff, the reverb wet value will be lerped to the target reverb wetness times the max reverb wetness, since normally a wetness value of 1.0 is very harsh, and the reverb room size will be lerped to the target reverb room size value. Alright, we now have all the functions we need, but we need to actually call them in order for them to do anything. Let's implement the physics process function. First, we'll update our last update time by using delta. This is more of an optimization, so you aren't calling Raycasts every frame. Next, we need to check if we should update our Raycast distance values. If so, we'll call onUpdate Raycast Distance to each raycast one frame at a time. Raycasts can be expensive, so we're just spreading all of our raycasts over multiple frames. Once we've updated all of our raycasts, then we'll reset the current raycast index and wait until we need to update this again. Now we need to check if the last update time is greater than our update frequency export parameter. If so, we need to find where the player is. For this system, it assumes that the player is the current active camera, so it grabs whatever the current active camera is and passes it to our update spatial audio function, which will update the target effects settings. Now in order for the target effects settings to get set properly, we'll call the Lerp parameters function, which will smoothly lerp the settings over time. Cool, we're finally done. Now we can take a look at how it actually works in action. I've added a few of these spatial audio player 3D nodes to my player object. It has some footstep sound effects and jump sound effects. I then added some CSG boxes in my world, making sure to set use collision to true and adding the collision layer 4, which I previously set for spatial audio collisions. Finally, I added in one of these spatial audio player 3D nodes to just play some music inside some of the CSG boxes to listen to the effect. Alright, let's check it out.
Huh. 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 Huh.
Anyway, this is a pretty basic system and could use a lot of improvements, but hopefully you learned something. That's all I got. See ya!